In this unit, we'll be looking at angles and parallel lines. This lesson is about the pairs of equal angles formed by parallel lines and a transversal.
Okay, hi everybody. In this video here we're going to take a look at angle relationships. This is going to be the first of a couple parts here. In this lesson, what we're going to be looking at, and actually for the remainder of this unit here, we're going to be looking at the properties of parallel lines. These are lines that don't intersect in two dimensions. Okay, so if you extend the lines out infinitely, because remember that's what we mean by a line, this extension that goes out infinitely, they will never intersect. And a transversal is a line that's going to cut through both of those. Okay, so we're looking at the relationship between the angles that gets produced in this particular scenario here. Now, something to note here: when you see two lines drawn here, you can't assume that the two lines are parallel. Okay, you can't just look at them and say, well, they look parallel, they must be parallel. Well, okay, no. In the question, though, they'll either tell you that they're parallel or they're going to use these little arrows here. So when you see the two little arrows, sometimes you'll see actually people put little triangles on there instead, but you see these little arrows here, that's going to mean that those two lines are parallel. So then you can assume that confidently. Now, when you've got the two parallel lines and you draw a transversal across it, okay, you get a bunch of angles. Okay, in fact, we get 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. And what we're going to start to do here is we're going to look for the different relationships that exist between these angles. Now, it turns out if we were to measure every angle that we're seeing here, all 8 of them, you would find out that there's only 2 angles. There are 2 angle measurements that we end up using, but they get repeated 4 times, each of them. And you can probably guess by looking at them what the relationships are here. You're probably going to notice here that 1 and 4, 5 and 8, okay, they are the big obtuse angles. They're all going to be the same. 2, 3, 6, and 7, they are these acute angles. They're all going to be the same. But right now what we're going to do is we're going to specifically look at some pairs of angles and give names to the relationships that exist between them, and give a name to the relationship that justifies for us why they're equal to each other. So to start off with, we are going to look at, way up here, something called corresponding angles. So now in this case, like it says here, corresponding means similar to or comparable. And if you could shift one angle up or down along, this is important here, along the transversal, then it would end up overlapping with this next angle here. So, and then we can also say that the angles occupy the same relative position at the two different intersections. Now, that might not mean anything until I actually point out what's going on, but they make an F shape. So, for example here, when we take a look at angle A, okay, right here, formed between this line and the transversal, look at the 4 angles there. Look at the 4 angles formed here. A and B are in the same relative location. They're both down and to the right, down and to the right. And those are what we call corresponding angles, and they would be equal to each other. Just like up here, okay, we've got this intersection. We're looking at the angle that's up and to the left. That's going to be the same as this angle down here at this point of intersection here, up and to the left. Okay, now, you're not exactly seeing that F shape there, but if you rotate that around, yeah, you do. So, from the 8 angles on the previous page, here are our corresponding angles. 1 corresponds to 5. 2 corresponds to 6. And so now we had just said that. Okay, notice those 2 obtuse angles correspond to each other. These 2 acute angles correspond to each other. 3 and 7, these 2 acute angles correspond to each other. Okay, 4 and 8, those 2 obtuse angles correspond to each other. And so there you go. Now, another relationship we describe as alternate interior or inside angles. Now, alternate means on different sides of the transversal. Okay, and interior means inside or between the parallel lines. And the result is kind of a Z shape here. So here are my parallel lines here. Here's my transversal. Okay, so parallel line transversal forms this angle. It's between the 2 parallel lines. When you compare that to the angle that's formed on the other side, Okay, these two angles are what we call alternate interior angles to each other. And they are equal to each other. Okay, that angle will be the same as this one. Now, where this gets difficult for some people is when like the system gets rotated and maybe stretched out a little bit like you're seeing here. Okay, it's sometimes difficult to see that this angle would be the same as this one. Okay, but bear in mind it's inside. Okay, it's in between the two parallel lines, and this angle and this thing are on opposite sides of the transversal. So yeah, that counts as a pair of alternate interior angles. So on our original diagram where we had them numbered here, there's actually two pairs of alternate interior angles. 3 and 6 are alternate interior. 4 and 5 are alternate interior angles. Another way that we can look at this are what we call alternate exterior or outside angles. Now, alternate again means different sides of the transversal, but this time exterior means outside of the parallel lines, not in between. And so in this case right here, I've got, here's my parallel line, there's my transversal, it forms this angle right here. On the other side of the transversal and on the outside again of the parallel lines, I've got this angle. Those two are going to be the same. Those are alternate exterior angles. And so from that original diagram I gave you with the 8 angles, we've got two pairs. One is alternate exterior to 8, and 2 and 7 are alternate exterior angles to each other. Now, for this particular lesson, we've got one more that we're going to look at here. We're going to look at vertically opposite angles. So vertically means around the vertex in this particular case here. I know a lot of times you think of vertical as up and down. In this case, it really means just around the vertex here and opposite sides of the vertex. So when you've got two lines intersecting, the angles formed on either side of that point of intersection, those are going to be equal to each other. Okay? So basically you're going to get this X shape. So these two angles are the same. And by the way, these two angles out here would also be the same. Okay? So on that, again, that diagram where we had the 8 angles drawn, I have got 4 different pairs of vertically opposite angles. 1 and 4 are equal to each other, they're vertically opposite. 2 and 3 are equal to each other and they're vertically opposite. 5 and 8, again, either side of the vertex, they're vertically opposite, they're equal. 7 and 6, either side of the vertex, they are vertically opposite to each other. Okay, so there's a bunch of rules. Now let's take a few moments here and just apply them. And hopefully after you do this a few times, you start to get used to the rhythm of how these things work here. Okay, let's take a look at a couple of questions here. So consider the diagram on the right. Okay, now, in spite of what I said a little while ago here, I didn't actually tell you that these two lines are parallel, so what we're going to do is I'm going to put the two little arrows there just to make sure that you understand. Those are intended to be parallel, and then there's my transversal. And so now I've got my 8 angles drawn out there. Now notice they are numbered a little differently than we did before. It's 1, 2, 3, 4, 5, 6, 7, 8. So we've kind of gone around clockwise. So what we want to do to start off with is we want to make sure that we are comfortable with the names of the relationships that we've just been looking at here. So we're going to take a look at 1 and 7. So notice 1 and 7. Here's the vertex, point of intersection. Here's the vertex, point of intersection. Okay, 1 is up and to the right, so is 7. So these are corresponding. Okay, those are going to be corresponding angles, and they're going to be equal to each other. 4 and 8. Okay, 4 and 8. Now, they are not in that same corresponding position, but notice they're both interior. They're both inside the parallel lines, and they're on either side of the transversal. So these are alternate interior angles. Okay, 5 and 3. Sorry, I don't know if you saw that here, but we're looking for angles 5 and 3. What is that relationship right there? There's 5. There's 3. Okay. Now, again, notice the point of intersection. Notice that in both cases we're below and to the left. Okay. Below the transversal to the left. So again, that means these are corresponding. Just a matter of getting used to the way that works here. Angle 6 and 2. 6 and 2. Okay, so they are not in the same kind of relative position in those points of intersection there. But 6 and 2 are both outside of the parallel lines. And they're on either side of the transversal. So these are alternate exterior angles. Okay. 3 and 7. Okay, 3 and 7 here. Again, they're not in the same corresponding position, but they are both between the parallel lines on either side of the transversal. So these are, again, alternate interior. Oops. And lastly, we're looking at 4 and 2. 4 and 2. Okay, now look, when you look at them and compare them to the point of intersection, they're both below the transversal and to the right. So these are corresponding. Okay, good. So let's take a look at the next question. Which angle is corresponding with angle 6? Okay, so we got to take a look here. Angle 6. So when I look at this point of intersection, angle 6 is above the transversal and to the left of the parallel line. So over here, above the transversal and to the left of the parallel line here, that's going to be angle 8. So which angle is it? Angle 8. And which angle is vertically opposite with angle 3? Now, vertically opposite angles are typically one of the easier ones to work with here, okay? So I look at number 3 here, and basically I'm looking for the little X that forms when that to create that angle. And on the other side of that is angle 1. And so that is exactly what the answer is. Angle 1 is vertically opposite to angle 3.